Welcome to lecture presentation for Unit 4, Part 1 of SC090 Foundations of Science. As we've done in the previous units, we'll begin with unit outcomes. Students successfully completing this unit should be able to describe the 4 tissue classes, explore the function of tissue types and their specializations, and describe organ systems and their functions. Week 4 is our last unit of study for this course. We'll continue our trip up the levels of organization and discuss tissues, organs, and organ systems. We'll get to know more about the different types of tissues and how they join to form organs and ultimately organ systems. As you can see here, we'll be covering 4 specific types. Later slides will contain more on muscles. We'll get into nerves and the nervous system. We'll talk about connections formed by connective tissue. We'll discuss what epithelium is and what it does. And again, we'll get further into the specializations, divisions, and cover some examples. Tissues. Let's start by defining tissue as something more than just a paper product used to blow your nose. Biologically speaking, tissue is a collection of multiple cells to form a more specialized structure. This specialized structure is capable of accomplishing more complex tasks than a single cell. It's able to raise its game, so to speak. For purposes of study, we've identified 4 types of tissue. Of course, scientists love to torment students, so we'll cover a few subcategories and examples of the different tissues along the way. First, let's identify the 4 tissue types. The 4 basic types are muscle tissue, nerve tissue, connective tissue, and epithelial tissue. If you hear of something outside of these 4, it's going to be a specialization of one of the existing ones. As an example, you may hear about cardiac tissue from the heart. Cardiac is a specialized form of muscle tissue. So we've got different flavors or different categories within each of the 4 main types. Our next slide is called More on Muscles. I think that's a good place to start. We tend to be fairly familiar with muscles, and we have maybe more of a working knowledge of muscle than some of the others. If we take a few moments to reflect, we actually know quite a bit about muscle tissue and muscles as a whole. So you need to start from a position of positivity and give yourself credit for what you know. Let's start with the technical definition. Muscle tissue is a collection of specialized cells which can contract. That means they can cause themselves to move. Muscle cells, and by extension muscle tissue, contain specialized sliding filaments or sliding fibers which are capable of producing movement. Muscle tissue comes in 3 varieties. And again, this is picking up what I had mentioned on the previous slide. If you're a meat eater, you're most familiar with skeletal muscle. This is the muscle of the trunk and the extremities. It's a collection of distinct bundles of voluntary, striated, which means striped. So muscle cells are voluntary, meaning we've got control, striped cells which work together to produce gross, large body movement. The next type is smooth muscle. By contrast, it's not subject to conscious control. You can't use your mind to make smooth muscle cells move. The cells are not striated, which means they don't have any stripes, and they tend to be arranged in circles or tubes. Smooth muscle is the muscle tissue of organs like the stomach and the intestines. Again, hopefully that helps you remember that they're organized in tubes or tunnels. Lastly, we have the most unique and rarest muscle type, cardiac. Cardiac muscle tissue is striated, striped like skeletal muscle, but is not subject to voluntary control, meaning it is involuntary tissue. You can't use your brain and go, okay, heart, beat, beat, beat. That doesn't work. It has its own pacemaking system. It has its own control network. Cardiac muscle cells are linked by very tight junctions that help control electrical signals and how they spread across the muscle mass of the heart. Make sure you clearly understand control voluntary versus involuntary, and striation pattern or lack thereof for each muscle type. So you can see on the slide there's a there's a handy chart where you can see skeletal, voluntary, striated. You're going to want to keep track of these details, not just for the exam, but for future knowledge. Let's explain epithelium now. The body has a variety of cellular sheets and layers which cover and line the body areas. These specialized sheets of tissue are called epithelium or epithelial tissue. In our expanded studies, we'll learn more about some of the different types of epithelium. For now, I want you to know that these types exist and have some fairly distinct properties. First, we have squamous epithelium. You may have heard of this in conjunction with squamous cell carcinoma, a form of skin cancer. You can remember squamous by its similarity to the word squash. Squamous cells are flattened cells which link to form broad sheets. Columnar epithelium. As seen in the name, these cells look like little columns or tall, thin blocks, neatly aligned next to one another. Lastly, we'll cover cuboidal epithelium, which consists of block-like cells packed into sheets and layers. Each of these tissue types can be used to create or define unique body areas. They can line cavities or they can separate regions. We can even see specialized pockets or pouches of epithelial cells which create and release body chemicals called hormones. These pockets of epithelium are called glands, and we'll study them in great detail in our studies later for the endocrine system. I want to jump over quickly and do a quick drawing for you of the three types. So let's get our pencil out. And I'm going to do turn my pen on. S for squamous, C for columnar, and then how about CO for columnar and CU for cuboidal. So if you look from above, a squamous cell might look kind of like a fried egg, but if you look from the side, it's flattened, and you'll see how they'll line up in sheets. And this sheet can form a wall or a covering. You can see this, for example, in your skin. If you were to look at a microscopic slide, you'll see squamous cells flattened, and they all line up and form a sheet. Incidentally, this is also kind of how the outer layers of your skin can flake off. Columnar from the side are just like the name indicates. They're columns, and they line up, and they form barriers. Because if you're coming from the outside trying to go in, let's say there's a needle going through or a toothpick because your brother or your sister pokes you, this is a lot to go through. It provides a lot of thickness. Lastly, you have cuboidal, which just as the name suggests, are cubes. They're kind of like columnar, but not quite as tall, and they form very regular linings, very regular sheets. So this can be very, very regular and very even. We'll talk more about it as we go forward. You'll see a lot more on this stuff when you get into your anatomy and physiology courses as well. Let's jump back to the presentation. I've always thought of the nervous system, and by extension nervous tissue, as the body's electrical system. Your body, much like a house, has a very specific system of wires. The wires run in specific directions and have specific jobs, at least if your house is up to code, which it should be. Some wires carry electricity to a room, and others carry it away. This is quite similar to the nervous tissue, a highly specialized network of cells which conduct electrochemical signals from our old friends sodium and potassium from our chemistry unit, from the brain to the body, or from the body back to the brain. Electrochemical signals are very fast, allowing for near instantaneous control of the body through a read and react system. So what are the takeaways from this slide? Highly specialized, directional, fast. The nervous system is very fast. It monitors and controls body activities, and it is based on our old friends sodium and potassium from our chemistry unit. Now let's jump into connective tissue. As you can see, connective tissue is very diverse. There's a lot of different information on this slide. And it possesses many subdivisions, probably more subdivisions than the other types combined. Generally speaking, connective tissue covers cell and tissue types which work together to connect and support body tissue types. Again, it's in the name. It's connective. It ties things together. This can be accomplished in a number of ways befitting the large number of tissue subtypes. We begin our discussion with adipose tissue, commonly called fat tissue. Adipose cells feature a very specific appearance. It looks as if the cell's contents have all been smashed to one side of the cell, and about 95%, that's not an actual estimate, that's just a colloquialism, about 95% of the cell is filled with a fat droplet. These cells act as a storage site for fat and can be used to cushion or insulate body areas. If you're carrying a couple extra pounds, you know that areas where fat collects, it could be your hips, your thighs, your arms, your cheeks, wherever, it can be a little squishy. That's because the fat is very cushioning. It also helps provide insulation. In creatures like whales, which survive in very cold ocean water, that layer of fat provides insulation of the thermal variety and keeps the whale from losing heat to the very cold ocean air around it. Ocean air and water, excuse me. Next, we move on to areolar or loose connective tissue. These tissues are used to surround and cushion organs. So we've got another type that surrounds organs and cushions them. They tend to be filled with a springy, bouncy combination of collagen and elastin. You're going to want to remember those two. Flick your earlobe for a quick primer on the properties of collagen and elastin. Your earlobe should be a little springy, a little bouncy, a little wiggly, almost kind of like a rubber eraser on a pencil. From here, we have a great contrast in dense connective tissue. If you've ever chewed on a piece of meat and encountered a tendon or a ligament, and again, more on these guys in a minute, but if you've chewed on a piece of tendon or ligament, you know about dense connective tissue. This tissue is very strong and has a very high tensile strength. These tissues hold bones and muscles together even under the tremendous stress of running, jumping, falling. From here we can jump to the fourth tissue type, supportive, which we'll get to on the next slide. Let me draw a quick picture for you. So again, we need to clean up our board. So let's take a look at an adipose cell. It's got a normal cell membrane, but there's a bump here, and all the cell's contents, all the organelles that we talked about are pushed over to one side, and then all of this is the fat droplet. So the bulk of the cell's interior, that 90-95% I talked about, is a droplet of fat pushed off to one side. I'll switch my color back. Later on, I talked about dense connective tissue, and we might see it in, for example, a tendon or a ligament. And what you'll see is a lot of long, linear type fibers. You'll see a lot of collagen in there, but it's all lined up in a linear fashion because the stresses on this ligament or tendon tend to be very linear, and it's very, very strong. It's going to resist, so it's going to hold. Let's say you've got a bone here and another bone here, and this is a very crude drawing. But it's going to connect these two and keep them from separating. The loose connective tissue, you're going to have a number of cells in this loose connective tissue, but the collagen isn't going to line up. The collagen and elastin are kind of seemingly randomized, so it's almost going to create cells And this stuff is very bouncy like your earlobe. Let me clean this up and then we'll go back to the presentation. We move on now to supportive. Within this family of connective tissue, we see 4 additional divisions. And again, you're going to want to pull out your note cards so you can keep track of this. You're going to want to review this, write this down. Within the family of connective tissue, supportive connective tissue, we have 4 divisions. I want to pause for a second and keep things organized. The global tissue definition, then we have 4 tissue types, which include connective tissue. Then within connective tissue, we have supportive connective tissue. And within supportive connective tissue, we have bone, cartilage, blood, and lymph. So it's like a tree. You know, we start with tissue, then we move to the types. Then within connective tissue, we have supportive. And then finally, at the end of the branch, we've got the supportive connective tissue types of bone, cartilage, blood, and lymph. Let's handle them individually. Bone. Again, we have something we're familiar with. If you've ever had a classic meaty entree like ribs, pork chops, roast chicken, you've seen bone. You know it's a distinct body tissue which is hard, contains rock-like stuff, tends to be very rigid, and provides a lot of support. Technically speaking, all of those components that we talked about, the hard, kind of white crystally stuff, is minerals, meaning bone serves as a place where the body can store nutrients for later use. That's an important and often forgotten aspect of bone, is it doesn't just provide support, it also provides storage. Bone is even active in creating blood cells. Again, if we break a bone apart and you look inside, especially like a thigh bone, you'll see this fatty stuff called marrow, and the marrow is where blood cells can come from. Again, very important to remember, bone isn't just this dead, inert, white crystalline stuff. It's a living, dynamic tissue which helps create blood cells and helps store nutrients. As we continue our exploration, we also see cartilage tissue, another tissue seen when we eat meat. Cartilage is the spongy, slippery, soft tissue that covers the ends of bones. It acts as a cushion for bony impact areas. For example, you've got a lot of cartilage in your knee, and that absorbs a lot of the shock when you run. This next bit may surprise you, but blood is also a connective tissue. While it is a collection of fluid and cells, the blood actually connects, and I want you to remember that, connects different body areas and ensures the transport and circulation of body chemicals, chemical agents, nutrients, cells, oxygen, all sorts of important stuff is transported, connected to the blood. Lastly, we have lymph tissue. The lymphatic system acts as a secondary transport and recovery system, which helps preserve fluids lost in our body tissues. It collects water in some cells which escape and returns them to the circulation. So again, the circulation of blood is a very fast process. The lymph is a secondary, slower kind of recovery system. As fluids leak out of your tissues, leak out of your blood vessels, the lymph is there to kind of collect it up and return it back to the general circulation. This slide brings part 1 to a close. This is a great opportunity to review some key definitions. See the slide for the textbook key definitions of tissue, organ, and organ system. Work hard to keep them organized within your mind. This goes beyond just studying for an exam. The foundations you lay down now will stay with you every day of your career. This isn't just about A and P or whatever comes next. This is about preparing for your career. Everyone has bad days, gets frazzled, gets frustrated, struggle to get the words out correctly. Today's practice becomes tomorrow's perfection. We will continue this practice in segment 2 in just a few moments.